Today's lesson is geometric representation of vectors. My learning goal today is I can represent and perform operation with vector quantities by applying vector operations. By definition, a vector is a quantity that has both a magnitude and a direction. For a vector in a plane, it is convenient to use the arrow to represent the vector. The length of the arrow represents the magnitude, while the arrowhead indicates the direction of the vector. Compass directions are measured clockwise from due north. So this is different than geometry, where we're counting degrees from like what I'd call east. So due north is here, and clockwise is positive. So taking a look at this vector, the vector has a magnitude of 5. So that would be the hypotenuse when I break it down into a triangle. And a compass direction of, I know this is 90 degrees, so 90 plus 20 is 110 degrees for my compass direction. So 110 degrees from north means I'm moving to the east in that direction. Okay, two vectors are equal if they have the same magnitude and direction. Their position doesn't matter. So taking a look here, vectors u and v are equal, even though they're in a different position. Okay, vector operations. We can add, subtract, and do scalar multiplication of vectors geometrically. The method is called tip to tail. I simply place the tail of each successive vector to the tip of the previous vector, and then the resultant vector is drawn from the first tail to the last tip. All right, let's do a couple of these. Okay, so the first one is asking to do a multiplication, 2 times vector u, and we're calling that scalar multiplication. So I'm taking a number and multiplying it times a vector, and my result is a vector. Okay, so I want to break down each vector into the horizontal and the vertical components. So I'm going to break down vector u, so the horizontal and the vertical. So the horizontal is 1, 2, 3, 4 to the right, and 1, 2, 3, 4, 5, 6, 7, 8 down. Okay, so I'm looking at what I have. So if I want to know, to figure out where to start on my graph, I'm just going to sketch. So I know I'm drawing tip to tail, 2 vectors that look like this. So I'm going to start more towards the upper left-hand corner. It doesn't matter which one. And then I'm going to draw 2 that go 4 to the right and 8 down. I'm going to start here, 4 to the right, 1, 2, 3, 4, 8 down, 1, 2, 3, 4, 5, 6, 7, 8. Here's my first vector. And the second one, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. So here's my tip to tail. So I'm drawing tip to tail. So this is vector u and vector u. And then my resultant vector is from the original tail to the end tip. So this is vector 2u. Okay, so let's do vector u plus vector v. So let's do the same thing. Let's break down vector v into horizontal and vertical. So here's horizontal and here's vertical. So I have 1, 2, 3, 4, 5, 6 to the right and 1, 2 up. So 6 to the right and 2 up are the horizontal and vertical components. So if I want to just have an idea where to start, I know I'm going to do vector u and then add vector v. So it looks something like this. So if that gives you an idea where to start. So vector u is 4 to the right and 8 down. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So here is vector u. Now vector v we said is 6 to the right and 2 up. 1, 2, 3, 4, 5, 6, 1, 2. So doing tip to tail, here is my vector v. So my resultant vector, so I start out at the first tail and go to the last tip. So this is vector u plus vector v. I can also subtract. So when I'm subtracting, I'm going in the opposite direction. So I'm going to really take vector u, vector u, vector u, and instead of vector v going up and to the right, I'm going to go down and to the left. Okay, so my vector u is 4 to the right and 8 down. So 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7, 8. So this is vector u. I'm vector v instead of going, so I want to know negative v. So negative v is really going to go 2 down. So 1, 2, and 6 left. 1, 2, 3, 4, 5, 6. So this would be negative v. So 2 down and 6 left. So I'm going to go 2 down and 6 left. So 2 down, 1, 2, and 6 left. 1, 2, 3, 4, 5, 6. Oops. So tip to tail. So this is negative v. So my resultant vector starts out at the original tail and the last tip. So this is vector u minus vector v. Vector v minus vector u. So v, I'm going to go this way, and then u will be going this way. So I'm going to start down here. So vector v, so vector v is going to be 6 to the right and 2 up. So 1, 2, 3, 4, 5, 6, 1, 2. So here's vector v. And negative u is going to be 4 to the left and 8 up. So 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7, 8. So this is negative vector u. So then I'm going to draw in my resultant vector, so the original tail to the final tip. So vector v minus u. Vector v minus u. When I want to combine vectors, I can do more than 2 operations on a vector. So u plus 2v. So I have 3 vectors involved here. So I'm going to do u, which is down and to the right, and v, up and to the right. So vector u is 4 to the right and 8 down. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So this is vector u. Oops, not minus u, just vector u. And then vector v, I'm going to put in twice, which is 6 to the right and 2 up. 1, 2, 3, 4, 5, 6, 1, 2. 1, 2, 3, 4, 5, 6, 1, 2. Okay, so this is vector v and vector v. So my resultant vector, I start at the original point, the original tail, and go to the last tip. So this is vector u plus 2v. Okay, number 6. So 2 times u minus a half times v. So vector u, 2 times u is going to go down and to the right, and a half times negative v, so to the left. Okay, so u is 4 to the right and 8 down. So I'm going to start here, 4 to the right. 1, 2, 3, 4, and 8 down. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7, 8. So these are vector u, tip to tail. And then vector v is going to be half, so that would be 1 down and 3 left. So half of v, 1 down and 3 left. 1 down and 1, 2, 3 to the left. Oops. There we go. Sorry about that. So this is going to be vector negative half of v, vector v. And then I'm going to draw in my resultant vector. So from the original tail to the last tip. So this is 2u minus a half of vector v. Okay, so this is finding my resultant vector from tip to tail when I have more than one vector. So next, let's talk about what the magnitude. So the magnitude of a vector is written The most correct way is to put it between two double lines, but sometimes there's some software, so it looks like it's just in between absolute value. But the most correct way is between two lines here, and that is the length of the vector. So it would be considered the hypotenuse of a right triangle. So if I broke this down into horizontal and vertical components, so the horizontal component is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And 1, 2, 3, 4, 5, 6, 7, 8. So I'm not concerned with the direction. So I'm just looking for the hypotenuse. So a magnitude is a positive number. So the magnitude of vector u is going to be the square root of the two legs. So 11 squared plus 8 squared, which is 121 plus 64. I'm taking the square root. So for an exact answer, the magnitude of vector u is the square root of 185. If I want to round in 3 decimal places, this will be 13.601 rounded. So this is the hypotenuse of a right triangle. So I'm finding the magnitude is the hypotenuse when I break down into the horizontal and the vertical components. Okay, now we're going to loop back to the first unit with trig and apply some concepts to geometry and what we talked about with the unit circle and right triangle trig when we first started. So I need to understand the notation to know what the question is asking. So when I have vector AB plus vector BC, the answer is the name of the vector. And if I have those double lines, I want to know what is the magnitude of vector AB plus the vector BC. So this one with the double lines is telling me magnitude. So this is a number. Okay, so I'm going to chain this back into using a parallelogram here. If I'm asking you to find from vector AB to BC plus vector BC, it's asking me the name, so the resultant vector, from the tail to the tip is going to be vector AC. So the name is vector AC. And then the magnitude, so we're talking about, we have a parallelogram. So my opposite sides are parallel. So if this side is 6 from geometry, I know this side is 6. So to find the magnitude, I don't have a right triangle, so I'm going to use the law of cosines. So the law of cosines, we went through in December. So the law of cosines is going to say the magnitude of vector AC squared. So I'm finding a side. So it is my two sides squared, 9 and 6. So this is going to be 9 squared plus 6 squared minus 2 times each side, 9 times 6, times the cosine of the angle in between. And I know in a parallelogram, consecutive angles are supplementary. So angle B is going to be 180 minus 55, which is 125 degrees. So this is going to be the cosine of 125 degrees. So make sure you're in the degree mode. Okay, one of the most common mistakes I see is forgetting to take the square root because this is the side squared. So the magnitude of vector AC is approximately 13.777 units. What about the magnitude of AB plus the magnitude of BC? So the magnitude of AB we said is 9, plus the magnitude of BC we said is 6. So the magnitude is going to be 9 plus 6, which is 15. Even though they're not in a line, this is how we add them, because we're putting them from tip to tail. All right, so AB plus B plus CD. So if I put AB, I'm going to do this so we can see it. So A to B which is 9, and C to D, which is 9. So tip to tail, I actually end up where I started from. So I don't have a vector, so it'd be a vector of 0, because I returned exactly to where I started from. So the magnitude of this would be 9 going to the right and 9 going to the left. So the magnitude is 0. But if I add the magnitude separately, this is going to be 9 plus 9. So the magnitude would be 18. So how I ask the question is really important. Okay, so pay attention to the nomenclature. Okay, that's it.